Bad data, it exists. I'm going to talk a little bit about it today. Not an exhaustive research on all kinds of bad data, just things I've seen and probably you've seen. Bit about me. I run Logarithm Labs, provide technical and strategic data consulting services. Before starting Logarithm, I worked at Google on the TPU hardware, which is the machine learning accelerator on infrastructure and analytics. I worked on FPGAs, which are programmable hardware devices, at Xilinx, which is now part of AMD, and a couple of other companies. But my background before doing data work was as a hardware designer. Okay, so starting with why, why are we talking about bad data? Why is it interesting? So what are the consequences? So bad data has consequences. What are some? If you present analysis based on bad data, people will mistrust the analysis. And you lose a bit of credibility within either your org or your exec team, things like that. Bad data also leads to data project failures or delays. You make some assumptions about the data, and when you encounter things which are not what you expect, then you end up with delays. It's very hard to explain these sorts of delays to various stakeholders within the organization. In general, bad things happen when you have bad data. So just to keep that in mind. The second thing around is why do we have bad data? Where does it come from? So one recent trend that I've seen is people are trying to repurpose legacy data to address new use cases, and there's a good reason for doing that. A lot of enterprises specifically have lots of old data, and most of the time it has been used for workflows and things like that. But people are trying to repurpose them for machine learning and predictive sort of models. And so going back to old legacy data, that's one source where the data might not have been collected for its intended use. And the second is depending on the organization, is the data that's collecting and that you're analyzing, is it part of a primary use case, right? For making recommendations, or is it part of a peripheral use case? You're collecting data as part of a workflow, but then you're trying to analyze it to make some predictions about the future. And human errors, obviously, if there are places where humans are entering data, then you end up with bad data if it isn't validated. And so the reason I decided to actually make this talk proposal is, if you're starting a data project, or if you're already part of a data project, you should think about bad data scenarios and try to improve the odds of success. You'll hopefully see some gotchas that you can avoid, but also you communicate better with the rest of the organization about the quality of data and such. And if you have a chance to collect data for whatever use case it is that you're addressing, keep in mind that the methods that you use to collect data could either make it good data or bad data. So before we talk about bad data and what sorts of things they are, what is good data? And so there's a definition, well-known definition by Hadley Wickham, called tidy data, and this is kind of how data is organized, where every variable is a column, every observation is a row, and every type of organization is a table. And this is a good way to think about how to organize data sets. And beyond just the formats of how data is stored, you should think about a well-defined schema, a data dictionary, defining the columns and data structures, make sure columns have consistent data types, and provenance, which basically means try to understand where the data that you're analyzing or using for downstream use cases came from. So, I mean, another observation is good data really only exists in tutorials. Bad data exists most other places. And there isn't a clear definition of what I mean by bad data. It's kind of messy in different ways. In large enterprises, depending on what corner of the organization you're on, Excel is often used as a database. It's convenient and easy, and everybody understands it. But it's also manual. Many processes that are captured in Excel are manual, and they lead to errors. Inconsistent formats, often currencies, date times, you'll see big variations in those sorts of things. Text formats, this is again like across industries, every domain tends to have some text formats which are optimized for human readability because people are reading those reports, but they're very hard for machines to parse correctly. And then you have to write all these parsers which end up with errors for downstream use cases, and they end up with errors. Units of measurement, if you work with anything which is like a physical thing, then you usually will refer to things like width, thickness, or distance, time, things like that. Also, large organizations, languages and geographies, they you'll see like you can't always assume that the data you're getting is in English. And for analysis downstream, you might have to make some adjustments. Timestamps, like not everybody is using the ISO formats, so local dates and times often introduce errors in very unexpected ways, and we go through some example. US, we use MMDD, YYYY probably, and Europe and India, for example, uses the date for the day first, the date, month, and then the year. Manual, we talked about the manual data errors and typos. Again, like if they make their way through, it can lead to some odd conclusions that you can draw from your data. Also, people often have like small web applications that they're using to capture various kinds of data. And if you don't validate data when someone's entering data, say at a factory shop floor, an operator is entering results of some experiment and you don't have validation there, you'll end up with weird things. Many of these are captured by modern web applications, but some applications are legacy applications, and in an enterprise space, you have to deal with a lot of these sorts of things. There's also a lot of metadata which just gets captured in names, and you just have to be careful about those, because names are usually created by humans, and humans are very, very clever. So we talked about sort of all the reasons, sources. So we'll talk a bit about like how Excel, CSV variations, again, like kind of common use cases. So just take example of like a directory, like a shared folder or a directory structure. And these are kind of some examples I've seen about how people structure the data to address some use cases. So directory names, you have like a base directory. Within the directory, you'll have a product A, and then you have some test results on it. Sometimes the directory will have a date associated with it, like that. And same for product A, you have the test results. Sometimes these dates won't actually have a date. They'll have a word like latest. which also has the latest test results as of today, right? So this is also kind of meant for humans to consume. If you're parsing, you have to write some code to make sure latest is tagged the right way. When latest gets moved to a new date, you have to deduplicate your data, things like that. Then there will be clever users who'll go in there, make some modifications to the data. They don't want to touch the original, and they'll rename it to something with their name on it. Now you don't really know whether. Whether I should pick this modified data. Is this the real data, or is this latest the real data? I don't know. Obsolete, you made some changes, it's been pushed somewhere, and you say, okay, this data is now obsolete, but I don't really want to delete it, and so you'll end up with that. Capturing hierarchy. So let's say you have product A, which uses multiple components. People will create a data structure essentially by nested directories, and and you kind of end up the same, but there's an implicit hierarchy of how, what are the components within this product, and that is captured within the directory tree name. So like the point of all this is like you don't know like how these things are getting used. So when you're pulling data in from like a file-like structure, make sure you're always capturing the name, the file name, the directory name, things like that. So you can de-identify like the data, where the data came from later, and also create additional metadata, which is captured here. How exactly to do that depends on the situation. Now, this is another example which is common, fairly common. It's easy to handle, but it's fairly common when you're first reading a large repository of files which are in some text or Excel formats. This is an example where just the headers in one of the files is missing. You're reading like 1,000 files. One of the files is missing a header, and then when you take one data frame and you concatenate it with another data frame, you end up with this. These columns, which are obviously not the right columns. Here, again, this is just a made-up example where you should have batch, test name, result, and the unit of the result in one file. Those are the 4 columns you should expect. But you did a PD read CSV, and it didn't have a header, and so you ended up with something like this. Again, like a trick here is like as you're parsing files in, you can keep checking and then sort of stall. Otherwise, some of these reading large number of files can also take a long time, especially if you're accessing files over a network. Typos in column names. This again is a common scenario because somebody edited a file and introduced a space. So what you see here is, again, like you're reading a bunch of files and you see some extra columns that you don't expect. And like for the most part, like you open the file up, it also looks to be the same. And you obviously have like a space at the end here. I mean, there could be other typos like that, but these are pretty hard to visually inspect and catch. Values, again, similar things like slight variations. Here it's not the column name, but like the test name is a categorical variable. If you think about, there are only certain kinds of tests. Now you're trying to do a group by to find the maximum, which of these batches had the maximum strength in the measurement or thickness in the measurement. You end up with seeing like 2 things in your group by aggregate, and that's obviously not correct. And if you present the data out, then you're obviously presenting incorrect data if you're not careful about this. This is easy to see because you only have 4 categorical, or you only have 3 categorical variables, and that there should be a fourth, but you should do things like strip spaces and run value counts or find the unique values in a particular column to make sure that that you don't have these typos which cause downstream problems. Units is another thing. We saw units was one of the columns. We weren't making any use of it. But imagine like there are other values you're adding to the table. Something like a visual inspection, which either says this product is acceptable, like the finished quality, the product is acceptable or not acceptable. And somehow this gets into the same column that has numeric values in it. And and of course, like numbers, we know how to handle max-min things. When you have words in them, again, here you're trying to do a group by and aggregate of the max and min. The order of what is good and bad, like that might not. So there's like an order 0, 1, 2 that you implicitly have in mind, which might not match alphabetical order. And again, like issues with like capital letters or small letters, you could end up with bad things. Another example, again, like from a real life example here is you're doing some measurements out of a factory or an instrument or something like that. You're doing batches. You get a new instrument where say the instrument's able to measure things more accurately, but they change the unit in which they report the measurement. So here, let's say you went from millimeter thickness to micrometer thickness because your instruments now are more precise, but your data sets haven't taken care of it. You didn't use unit. You didn't use unit in any of your calculations when you're doing group bys and things like that, and you didn't generate a new just a pure form a number taking units into account. So you'll obviously end up with something which is like 1,000 times more than what you had. Similar things like if you have like miles and kilometers or meters and meters and feet, things like those could get pretty dicey. Then I have this category of human ingenuity, which is really people trying to hack unvalidated data sources. So again, this is an example where like legacy application was used to collect data, and everything typically is nicely structured, but for a bunch of observations, there were 2 observations written into one row, and this obviously is not right. And if you aren't aware of that, then you'll either miss it, or when you're trying to join the batch number from one data set to another data set, then you'll end up with some either missing values or something like that. So something to be careful about. Again, like you can add assertions, you run some basic checks to make sure there's only one value, it follows a certain format. There's many ways in which you can validate it, but part of it is to figure out how did this bad data make its way into my database. And often it's like someone, when they coded it up, the application just works. When they coded it up, it didn't have any error checking at the data capture point. Languages, I talked about this a little bit earlier. When you have multinational sites, people entering data freeform, there's some guidelines, and if those guidelines aren't double checked, then you end up with problems. So again, like if we look at from this again, like from a real life example, multinational site, all of them working on similar things, and you end up with different words to describe the same thing. I mean, in this case, like Italian, German, and I think this is Korean. What you really have here is you have 3 ordered categories, but you have 12 values, and so somehow you need to map one to the other. So just be careful of that. Like if you are treating, for example, these things as ground truth data, then you want to fix the data, into the number of ordered categories that you have. So dates and months, again, multinational. sites pretty annoying when you run into this. So just to give you an example of like, these are silent errors that you wouldn't see, and often you have to use other mechanisms to disambiguate which data set came from where. So take this data set. All of these dates are supposed to be in March. So the top data set here comes from US, from the US presumably, and then the second data set comes from Europe or India. So you see here that all of these are in March, but when you take this data set, concatenate it, and do a PD to date time conversion, you end up with these two values, which end up in May and December, but all the other values, they stay. You see a warning like that, and if you see a warning like that, it doesn't mean that other rows in your data set were converted correctly. So in this case, you only have 3 warnings, but for 3 rows, but there are 2 other rows where you end up with incorrect incorrect dates. So yeah, just be mindful, careful. So if you have messy data, you still have to deal with it. How do you deal with it? There are certain techniques. Certain techniques, there isn't like one holy grail, but like I always try to understand how the data was generated, and this means asking questions to various people. They could belong to different teams, different parts of the organization. But once you understand how the data was generated, you're just more aware of what are the things you need to watch out for in terms of bad data. If you can work with those teams to minimize the sources of errors. When it's at the point of capture, then it's probably a good time, have a good time. And often this means like if it's in Excel, you have templates, and the templates have validations and things like that, and people generally don't mess with those. If you have web applications, then you have the assumptions about the data built into your validation so that people aren't able to enter bad data in there. But what do you do? Like when you have messy data and you have to go through a bunch of transformations, document all the assumptions about the data. I mean, oftentimes it means like if you have a notebook, don't just write the notebook. If you made some assumptions somewhere, then just write a quick assertion so that you either get like a log, something out in the logs, or the notebook execution fails so that you can go back and look, and you don't keep pushing bad data out into some other third system. Like if you're doing workflow steps, like taking one, automate it and make sure they're reproducible. These are all pretty standard practices. If you're using a big, like a framework like Metaflow or Airflow or something like that, that's fine. But if you aren't, and you're just running notebooks, hitting run all, then try to see if you can use make files, things like that. Use good naming conventions yourself. And think about the debuggability of the data. So what I mean by that is like a debugging code is like different process than debugging data. And if you're making some assumptions, write out into some logs or files, like aggregations, which you might not need. If you have expectations that there should only be five categorical variables in this column, write an assertion so that if something comes down, that you trap it, catch it, and you fix it at the source. And these are some tools that I typically use when I either am developing some new data engineering pipelines, and I'm seeing a data set for the first time, or I'm trying to ingest data that I haven't seen before, or it's a new data set I'm unfamiliar with. These are some things I use. There are many data tools available. Some of the simpler ones are actually quite effective. SQLite is one of them. It's really easy to use, and Specifically, I mean in the case of, there are many, many users of SQLite. I just mean like for the case of data transformation, you might have your data sitting on Snowflake or AWS or, or a shared drive. Fairly easy to use SQLite to pull that data in, capture it on a local file. It comes included with Python. There's zero setup. It's a single file. If you've never used it, you should try it. Most people have probably used it here, but if you haven't, you should try it. It's a single file, captures multiple files, data sets, and you can just email it to somebody or share the data with somebody if you're collaborating with them. Very, very easy to use. So the way I kind of use it for data transformation is like because it's quick and it's local. I might pull some data into raw format into a SQLite database and then start making transformations from there. And this might not be the entire data set, but just kind of like a subsample of data that, or even like if it isn't a huge data set, SQLite can handle large files. It's just local, it's very fast, and I can stage transformations. You can almost use it as a lightweight data versioning tool, either at the file level or at the table level as I'm making transformations. So it's quite useful for that. And using it is fairly simple. If you use notebooks and pandas, it's you just write to SQL and you name a table name here, and that table name gets generated. Now, another tool which I use, this is not a tool I have written. This is a tool from Simon Willison, who is a very active blogger. His blog is amazing, and the dataset, the tool called Dataset is also pretty amazing. This is picked up from just the first page documentation of the tool that he has done for exploring data of any shape, size. Explore it, publish it. So the way it works is I'm not sure if anybody has seen this or heard of this. It works only with SQLite databases, as far as I know. So it doesn't connect to Postgres or Snowflake or anything like that. And there's a pretty nice ecosystem around this baseline dataset tool. It's open source. So after installing it, you just pass it to SQLite databases, which are just files. And you get a web interface which has all the tables and the files. So as you're making transformations, for example, I start with some baseline, make some transformations, create a merged file. Then I can easily explore the data with three primary things: filter, facet, and sort. Those are ways to just see, okay, did my transformation work? How many different categories did I end up with before and after the transformations? Things like that. If you're looking for particular values, sort, you don't have to be in the notebook and kind of keep running pandas commands essentially as you're making these changes over and over again. So you make the transformation, you write it out, and you hit reload, and then you can see what you used to see before. Also supports SQL. So if there are some queries that you're constantly running after making the transformations, again, you just override the table, hit refresh, and you get back the new data. And so the process of iteration on a new data set gets fairly easy. So yeah, there were a bunch of examples here, and like, what are some key takeaways from this? Like, bad data exists in the real world. Spending analysis time looking at signs of bad data is not time badly spent. Like, this is time that is important for downstream. It's very hard to explain why this is time well spent. But if you're working in an organization, you should make an effort to essentially say, okay, before we start building these models or these dashboards or these predictions, we need to make sure that we're doing it on data which is good. And that is how you'll build credibility as well as accuracy within the organization. So just build good habits around this. Yeah, and if you're working with messy data sets, then everybody has their own sort of workflow. You should develop some good habits around that, so you can iterate through new data sets fairly quickly. learning how data was generated. This was very, very instructive for me as I went and talked to various people. So talking to people is actually good. Like, you shouldn't just stare at the screen. Go talk to some people. It's very helpful. Now, bad data in your databases is also a signal that there's something in your organization that needs to improve. So there's always opportunities to help your organization, even while dealing with bad data sets. Ask questions about, can we do anything to improve the efficiency? Can we introduce automation anywhere? You learn a lot more business context around your team, your group, and your company, and hopefully that'll do good things for your career. That's all I have to say. If there are questions, happy to answer.
How often do you hear, "Oh, this is John, just let the AI take care of this"?
Yeah, so that's a good question. Many projects I start out with, typically at the exec level, they want to, people want to use AI. Like, there's a lot of things that are happening with AI, and people want to use these modern things. So yeah, part of my job is just explaining that you need good data to train your models. You can't just throw like a directory full of Excel files at TensorFlow. It's not going to work. So how do you go about collecting the data so that you even have a shot at running a linear regression model, for example? Yeah.
What's your best answer for extracting data from a PDF file or a bunch of PDF files?
Yeah, so PDF files are really, yeah, so like where I have dealt with PDF files, I've generally used like an API from Amazon, like Textract, or document something from Google. Usually companies have that. The outputs you get from that are really low level. You can extract tables and things like that from within PDF files. But the low level output typically tends to be, here's a word, or here's a line, and here's the location, and you have to do something with it. Presumably some newer, yeah, I've heard that there are some newer products which handle that. But if there are specific things that I'm looking for in a PDF, for example, extracting just the words and searching. So like at a client, for example, they wanted to see whether the word, whether like a cosmetic was tested on animals, right? So, and a lot of the files were sitting in PDF files. So even just a text and just doing a text search on those works okay. But PDFs are pretty annoying to deal with. No good answer. Use APIs, I suppose. Yeah. Do you have a good answer?
No.
Does anybody have a good answer?
Not really, but a shameless plug or plea. Whatever I was doing, PyPDF seemed better than, and mine couldn't be calling out to a web service. It had to be all running on the machine. PyPDF seemed to be the least bad of the bunch. It's available in Conda for Linux or Mac. If you want it on Windows, it's in pip. It's still not in Conda. If anyone actually is handy with open source, please put it in Conda for Windows, please. Thank you.
Yeah, so there are like other kinds of PDF parsers too, where if the text in the PDF is actually text that you can select, like in a browser, or then it works. But often PDFs tend also to be images, and some of like you still need the OCR on the PDF, which is pretty annoying. Yeah.
I just feel like this whole presentation, someone's been looking over my shoulder for the last 10 years of my career, so thank you. You'd think it's 2023, we figured out Unicode by now, but I'm sure you've seen cases where non-Latin characters did funny things.
Yeah, I went through an example here.
We have where it's different translations, but also where it's...
Yes, yeah, like...
so at least here it's actually rendering, right? Because you could also have where it's like slash umlaut smiley because it doesn't know that that's a different language, but it thinks that's Latin 1, yeah.
But yeah, that, not much to do about that.
Yeah.
But Python 3, I think, handles all this stuff fairly well. Thank you.